Until now, the component sets we've looked at don't deal too much with geometry, and thus we haven't had to preview too many things here in the Rhino model. That's going to change now as we start to look at vector, curve, surface, and mesh in subsequent videos. The vector tab is a place that we have visited before. We went to vector point, and we were looking at construct point and a couple of other components in earlier definitions. Well, in the vector area, we have components to deal with, well, vectors, points, construction planes, and distributing points in grids and spatial configurations. We also have an area that is dedicated to fields. Fields are kind of a special part here in Grasshopper. They're pretty interesting and have some interesting applications. I'm not going to focus on them too much at this moment, but I do have a basic definition, which takes a couple of points that we define. It applies a negative charge to them and then evaluates how that charge affects a bunch of random points. You can actually select the points here, the point charges, and move them around. You get this interesting magnetic effect. You can do this in 2D and 3D. So you can play around with that definition if you like. Now I'm going to start a new document so we can look at what we have over here in grid. As I mentioned, there's a few different ways that we can distribute points. So here I'm going to look at the hexagonal grid. I see that I get a few hexagons here in a sort of array. So I have a few columns and a few rows of hexagons. I can change the size of the hexagon cell, and I can change the number of hexagons in each dimension. For example, if I bring down a slider, I'm going to make a slider here. I'm going to double click. I'll say 0 to 10, and I'll plug that into E of x. You can see that I can increase the number of cells in the x direction, and if I copy that, I can increase in the y direction as well. I have two outputs here. Actually, we get the curves, and out of the second is the center of the hexagons. If we look at params, geometry, and point, we can actually expose those. They're not shown by default, so those are the centers of the hexagons. We get a different cable here. This is actually showing us that we're passing a list of lists, and we'll talk about that in another chapter. I'm going to turn both of these off because I want to move on to a different component. I'm going to go to Vector, Grid, Populate 2D. This component essentially takes a rectangle, a number of points, and a random seed here to generate that number of points within this rectangle. So this is just random sets of points. If we change the seed to something else, for example, I right click here, set integer to 25, we get another set of random points. Let me skip over and see what we can do with that. I'm going to skip over planes for the moment. Here we have some basic construction planes, and we can construct planes in different ways. But I want to go over here to point and see what we can do with this random grid. For example, let's use closest point. I'm going to try to find the closest point to some point on this grid. I'm going to switch over to perspective. I'm going to reference a point. How do we do that? We go to params, geometry, and point, and I'm going to right click here and say set one point and click. We didn't have a point drawn in Rhino, so this is just a point that exists in Grasshopper. If I select it, and if we have display gumballs, when we select this point that's only drawn in Grasshopper, we can actually move it around. I'm going to plug this into P, and eventually the random points into C. P is the point, and C is the cloud of points to search from. The result is that I'm getting the closest point from this set to the point connected in P. Now what I can do, I'm going to cheat a little bit, and I'm going to draw a line between this point and the closest point in the other set. I'm going to actually go to curve, primitive, line, connect that to A, and the result from P to B. As you can see, what I generate is the closest point to my sample point, and if I move that around, notice how my line is changing to display the closest point. We can also do this with a number of points. So here we have vector point and the plural version, closest points. Let's try that one. I'm going to delete the closest point component, and I'm going to plug this one in. So I'll plug in my test point into P, the cloud of points into C. Here we have an optional value, which is how many close points do you want to find? By default, it says 3. Let's keep that. I'll plug P into B. Now I have something similar, but I actually have 3 points that I'm showing. And if I highlight the line as well, that might show up a little bit better. You can see as I move the point around, it starts to snap to the different points. In this case, the 3 closest points. As I mentioned, we also have components here to deal with vectors. We can start to deal with just basic unit vectors or construct vectors in all sorts of different ways. I mentioned briefly, but I'll just come back to it again before we finish the video, that we have a section here for construction planes. This is going to be important when we start to generate other kinds of geometry, for example, curves or surfaces that depend on a construction plane. Well, we can construct here different planes and eventually have the curves or surfaces or other geometry get oriented to those construction planes.